chemical equilibrium. Chemical equilibrium. We are going to continue with our chemistry class with this topic, chemical equilibrium. And now we have a question on the board. The question says, calculate the composition of the equilibrium mixture obtained from the reaction of 1 mole of ethanoic acid with 4 moles of ethanol in the following equation, this equation. Given that the equilibrium constant K is equal to 4 at the temperature of the reaction. So we need to get the composition of the mixture. The composition of the mixture. That means at the equilibrium, what quantity of ethanoic acid that will be left, what quantity of ethanol that will be in the vessel, and what quantity of ethyl ethanoate, this is an ester, that will be formed, and the quantity of water also in the vessel. It is what we need to get. Now, before starting, I write here initial stage. At the initial stage, we have 1 mole of ethanoic acid, is what they say there, 1 mole of ethanoic acid, I put 1, and they say 4 moles of ethanol, I put 4 there. 1 of acid and 1 of ethanol. And how many moles of ester here? There is 0, because at original stage there is nothing that is formed. And also here 0, because nothing is formed. Now, the change that's going to occur at certain stage we're going to have X quantity that is going to be consumed. X quantity is consumed. And also here, X quantity is consumed. Why X and X? Because we see that ethanoic acid and ethanol, they react in the ratio of 1 to 1. And because it is consumed, let me put minus and minus. And what is consumed here is what is formed there. So what is consumed here and there, it is exactly what is formed there. Put X and X. X and X. So here is consumed, and the same quantity is produced there. Is plus. Is plus. Now, at equilibrium, what quantity of ethanoic acid that we're going to find in the vessel of the reaction? At equilibrium, we are going to have 1 minus X is the quantity left in the vessel at the equilibrium. So originally it was 1, but X has been consumed. Then at the equilibrium we have 1 minus X. And here we're going to have 4 minus X is the quantity that you are going to find in the vessel at the equilibrium stage. And over there we are going to have X and X. From there, we need to write the equilibrium constant expression. The equilibrium constant expression that we need to write. So, I'm going to wipe here to get space, okay? Because I hope that you already took down, you already copy the question. We have it in your copy, and then I'm going just to wipe it so that I can get space there. Now, we need to write the equilibrium constant expression here. The equilibrium constant expression will be K is equal to the concentration of ethanoic acid I made a mistake. The concentration of the ester, because on the top we have to write the concentration of the product at the top. So CH3, COO, C2, CH. The concentration and multiply by the concentration of water. And then divide by the concentration of the ethanoic acid multiplied by the concentration of ethanol. As I already said, at the top we do the multiplication of the concentration of the product, because we have this is a product of the reaction, this is also a product of the reaction. So we put them on the bracket, the square bracket. In chemistry, the square bracket means concentration. Okay, this is concentration. So this square bracket is concentration. So the concentration of the ester that we have multiplied by the concentration of water divided by the concentration of ethanoic acid multiplied by the concentration of ethanol. Now we are going to replace now in this expression, we are going to replace them by, so we're going to replace this by 1 minus x and that by 4. No, sorry, we're going to replace this by x, okay? We're going to replace this by x, and we're going to replace this also by x. And then ethanoic acid will be replaced by 1 minus x, and then ethanol will be replaced by 4 minus x. Okay? Now, I'm going to put there. I'm going to replace there, but I put there x multiplied by x. So concentration of ester multiplied by the concentration of the water divide by the concentration of ethanoic acid was 1 minus x multiplied by the concentration of ethanol. Look what we have, and this has to be equal to 4. Remember, 4 is the equilibrium constant expression, the value. So 4 was the value of K that was given. So we do like that. Now, from here, we are going to have x multiplied by x will give x squared at the top. At the bottom, we have 1 multiplied by 4 gives 4. 1 multiplied by minus x we give minus x. Minus x multiplied by 4, I get minus 4x. Minus x multiplied by minus x, I go to get plus x squared is equal to 4. Okay, so 4 minus x minus 4x plus x squared. Now, from here, this will give what? This will give x squared 4 minus 5x plus x squared is equal to 4. And from here, we are going to do cross multiplication. Cross multiplication. So, this multiplied by 4 is equal to x squared. Okay, it is what we are going to do. This multiplied by 4, so we get 4 multiplied by 4 minus 5x plus x squared is equal to x squared. Okay, so we get like that because we do cross multiplication. Why cross multiplication? Because 4 is like 4 divided by 1. We can write the 4 like that, 4 divided by 1. And then we do what we have here multiplied by what we have there. And then what we have here multiplied by what is there. So this multiplied by this will be equal to x squared multiplied by 1. It is what we got there. And from there, I continue. 4 multiplied by 4, we get what? 16. 4 multiplied by 5x, I get minus 20x. 4 multiplied by x, I get 4 multiplied by x squared, I get 4x squared. And that equals x squared. Okay, I'm going to rearrange and bring this to bring x squared to the left hand side. So what I'm going to rearrange this first. If I rearrange, I get it 4x squared minus 20x plus 16. So this I can rearrange it like that. And then it is equal to x squared. Now if I bring x squared to the left, I'm going to have it minus x squared is equal to 0. Nothing is left there. From here, we're going to write what? 4x squared, take away this, get 3x squared, okay, 3x squared minus 20x plus 16 is equal to 0. Look what we have. 3x squared minus 20x plus 16 equals 0. Now from here, we are going to use our quadratic formula that we know in mathematics, that we usually call a minus b formula. Okay, minus b formula, that is a quadratic formula that we are going to use to solve this. Okay, so I need to get a space here. I hope that you understood the steps that we have so far. Okay, now I write now 3x squared minus 20x plus 16 is equal to 0. Now, minus b formula, or quadratic formula that we are going to use, x will be equal to minus b. Minus b is minus 20. Minus b will be 20 plus minus, the formula says b squared. B squared will be minus 20 squared. Minus 20 squared. B squared minus 4, A is 3, and the C is 16 divided by 2A. A is 3. Okay? Look what we have there. Now we are going to solve. Are you okay there, Joanne?
Yes.
Okay? Okay, thank you. Now we continue. Here we are going to use my calculator to solve, to get this. 20 plus, I put plus, square, 400 there, multiply by I got x is equal to 5.73 moles. So, or if I use minus, this when I use plus, when I use plus there, I get this. Now, if I use now minus, let's go to see what I'm going to get there. So 0.9 to, so 0.93. So x is equal to 0.93. X equals 0.93 moles. So now, look, we have two values here. We need to criticize. We're going to criticize 5.73 moles and 0.93 moles. This is not valid. Why? Because we cannot go from 1 mole from ethanoic acid, 1 mole of ethanoic acid at the beginning, and to have 5.73 moles. That means at the equilibrium, go to have 1 minus this. That's going to give minus 4, something like that, minus 4.73. This is no, and it doesn't exist. A minus 4 moles, it doesn't exist. That's why I say this is not valid. Okay, this answer is not valid. The only valid answer is this one. We have the value of x. Now, we need to get the composition at the equilibrium. Remember, we had at the equilibrium, we said that for ethanoic acid, the concentration of ethanoic acid, we said that it was 1 minus x. 1 minus x. We replace x by 0.93. So then what we get there, 1 minus 0.93 is 0.07 mole. This is the concentration, the number of mole of ethanoic acid at the equilibrium. At the equilibrium, we have this number of mole for ethanoic acid. What about ethanol? Ethanol. Remember ethanol, it was what? It was a 4 minus x. 4 minus x. So we are going to write 4 minus 0.93. So 4 minus 0.93, and then we have 3.07 mole of ethanol. So at the equilibrium, we have this number of moles for ethanol. What about the ester that we had? So the ester was so this, remember, for ester it was x. For ester it was x, and the x that we got here is 0.93 mole. The same for water. Water will be also the same quantity for water. Okay, so water, I put it like that. So the quantity of number of moles of water is equal to the number of moles of the ester, and it is equal to 0.93 moles. We have now the composition of the mixture in the vessel at the equilibrium. And we're going to finish there. I leave it for you to understand.